Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we'll solve some problem related to viscosity of fluids. In our previous lecture, we have discussed the theory part of viscosity, kinematic viscosity and Newton's law of viscosity. So let's solve some problem related to viscosity of fluids. So I have taken an example. If the velocity distribution over a plate is given by u equal to 2 by 3 y minus y square, where the u equal to the velocity in meter per second at a distance y meter above the plate, calculate the shear stress value at y equal to 0 and y equal to 0.15 meter. Consider the dynamic viscosity of the fluid is 8.63 poise. So let's see how to solve this one. So here the velocity distribution given y equal to 2 by 3 y minus y square. Okay, so we know that what the formula for shear stress. So from the Newton's law of viscosity, we know that tau equal to mu into du by dy. So here we need to first find out the derivative of this u. So derivative of u with respect to dy, okay, we'll get the value here 2 by 3 minus y square, derivative of y square, that is here 2y. Okay, now again we need to find out the value of du by dy at a distance y equal to 0. So y equal to 0 means at y equal to 0 we'll get du by dy. What we'll get here, if we put the value of y equal to 0, this part will be 0, then this will be 2 by 3. So 2 by 3 we can write fractions 0.667. Okay, and second part is what, again at y equal to 0.15 the value of du by dy equal to again 2 by 3 minus 2 into 0.15. okay, so that means 0.667 minus 0.3. So here you will get 0.367. okay, and now we need to find out the value of tau, shear stress. So again in this question, if you see dynamic viscosity is given 8.63 poise, so mu equal to 8.63 poise. So this one we can write in terms of Newton second per meter square divided by 10 means we'll get, divided by 10 means we'll get the Newton 0.863 Newton second per meter square. Okay, now just find out the value. Tau at y equal to 0 equal to 0.863 into what will the value here, 0.667. this is one value, and similarly tau at y equal to 0.15 equal to, you can get similarly 0.863 into 0.367. okay, now let calculate this with the help of this calculator. So how much is here, 0.863 into 0.667, so 0.575, 0.575, this is our Newton per meter square. okay, similarly again we can calculate 0.863 into 0.367, so that is 0.316 Newton per meter square. okay, so this is one problem related to viscosity. Let's solve some other problem similar to viscosity of fluids. Another question I have taken, a distance between the moving plate and a fixed plate is 0.025 millimeter. So this is a moving plate and this is a fixed plate. okay, suppose this is the fixed plate is there and this is moving plate is there, and the distance between these two is given how much? That is the thickness given 0.025 millimeter. So that means we can say the thickness given dy given here 0.025 millimeter. So this one we can convert into meter directly. So we'll keep it here like this, 0.025 into 10 to the power minus 3 meter. Okay, and this is moving with the velocity. The plate, the velocity is moving is 60 centimeter per second. So the velocity, let's consider u, which is moving with the 60 centimeter per second. This also you can convert into meter. So 0.6 meter per second, and it requires a force of 2 Newton per meter square, which requires a force of 2 Newton per meter square. And so that is nothing but your shear stress given directly. So tau equal to 2 Newton per meter square. So what you need to calculate? Determine the fluid viscosity between the plates. So what is the viscosity between these two plates need to be calculated. So again, similar formula is there. We know that as per the Newton's law of viscosity, tau equal to mu into du by dy. Okay. Now here tau given, we need to calculate the mu. So what we'll do, mu equal to, I can write tau divided by du by dy. Okay, so already tau given 2 Newton per meter square given it is, and now here du here you can see that velocity, that you can say final velocity or moving velocity is given 0.6, and what about the initial velocity? You can consider 0. So this 0.6 minus 0, that will get 0.6. So 0.6 is the du, and dy is here 0.025 into 10 to the power minus 3. So this bottom one, like denominator one, we can take it to here numerator. So that is nothing but 0.025 into 10 to the power minus 3. Okay, and now if you solve this, let's see how much it will come. 2 into 0.025 divided by 0.6. Yeah, so that will get 0.083, or else if you take 2 digits to that side, so we'll get equal to 8.3 into 10 to the power minus 5 Newton second per meter square. Okay, we'll get the value 8.3 into 10 to the power minus 5 Newton second per meter square. So this is our viscosity of the fluid which is flowing in this. Okay, this is one simple problem. Let's see another one problem here. A flat plate of area 1.5 into 10 to the power 6 millimeter per millimeter square is pulled with a speed of 0.4 meter per second, is related to another plate located at a distance of 0.015 from it. Find the power required to maintain the speed if the fluid separating them is having a viscosity 1 poise. So this is somehow difference, like we need to calculate the power required to maintain the same speed. So again, one more steps need to include here. That's it. No other things is there. So here area is given. Okay, 1.5 into 10 to the power 6 millimeter square it is given. Okay, now then with a speed, that velocity given 0.4 meter per second, and distance given here y located at 0.15 millimeter. Okay, and viscosity given, viscosity we can see that is given 0.1 poise given, sorry, this is given 1 poise. So here we need to calculate very simple the power required to maintain the speed. So directly again I'll tell you, this is, we can write 1 by 10 Newton second per meter square. Okay, so we know that tau equal to mu into du by dy. Okay, this is the point. Now here tau also not given, so we need to find out tau. So first mu equal to mu value is already given here, mu equal to 1 by 10. So mu equal to 1 by 10, and this velocity is given, change in velocity, this is 0.4, and dy is already given 1.5. This is given in millimeter square. I just need to change into meter square. Okay, so directly you can write this is minus 6 given, not 6. No, 6 given actually. So this 6 we can convert into meter square. It will be directly 1.5 meter square will be there. So this one 1.5 meter square. So 0.4 divided by d. This is area actually. This is not required. Y given here, yeah, 0.15. So 0.15 millimeter we can convert into meter. So by writing this one 0.15 into 10 to the power minus 3 meter. So if we solve this one, we'll get the value of tau. So near about 40 means 3, 15 will get here. 266 will get, I think, this one. 0.4 divided by 0.15. Yeah, 2.66 into divided by point will be there, that is near about 266.6 Newton by meter square. Okay, so tau we got. Now the next thing is we need to find out the power required to this one. So power required is nothing but we required actually P equal to force into that velocity applied. So we need to find out the force now. So force equal to, we can calculate tau equal to, we know that force by area. Now force equal to tau into area. So area is nothing but given there. So 266.6 into this area is 1.5. So that will be nothing but into 100 into 1.5. So near about 400 Newton. So 400 Newton we can multiply here, 400 Newton into this one 0.4. So near about 160 watt power required. Okay, so like this we can solve any problems related to this viscosity of fluid. So I hope you understood related to this problem of viscosity of fluid. If you are having any kind of doubt regarding this, you can give a comment on the comment box. Thank you all.